So, guys, in addition to the previous video that I made on this topic of simulating a crack, to using a 2D body in Becker software, I am extending that to for extending that further to have a crack which is away from the edges. So, as you can see here, it is closer to one edge. So, we will go to make it away from the edges. This editing of the editing of the location of crack now can be done just by going to this and you have to edit it, right click and then edit. So here we see that I've done the editing, preliminary editing, but if we want to move this location, what we have to do is we have to set a dimension for this to this edge, and now it is 10. So what I have is, I think this is 100. So we can, so this is 20. So 20, like we have to make it 40, make it equal from all the direction, all the sides. So now it is at the center. So this is now we have edited it. We can close it. Done. So once this done, we have to just right click the features and regenerate. So it has come to the center. So we have to go and ensure that the since okay, so we have to go and ensure that the geometry of the crack and all is so just see the scene. Have to visualize the scene, assign scene. No, not assign scene. We have to just ensure the scene is properly is there on it. The crack is not there. Scene, let us assign the scene. Let us ensure that the scene has been deleted and assign the scene. So what I'm going to do is assign the scene by holding the shift key and clicking the line which represents the crack. So this line only represents the crack. The other circles are created just to aid the control integral process. So now we see that there is the line between them is bolded to tell the software that this is a crack and to create the duplicate nodes at these locations while meshing it. So having done that, we have to go to next loads and all. I have not. I have to just see that it is already remaining the same. Then meshing. Meshing, we have done something to this region. So we have to do same thing for this. There is a chaha. One thing we forgot, now that it is an internal crack, so it is different from the edge crack. So we have to define crack for both the ends has to be defined as two separate cracks, even though it is a single crack. But for the software, from the mathematics point of view, it is actually two things because the main thing is control integral thing works for only one circle. So if we see this crack, sign same, okay, it's the same. To continue crack, I think I defined the crack now. Is it not available? Let us see. Crack. Okay, I did some mistake where the crack is not assigned, so I have to do it again. I think the crack got deleted. Oh, okay. I think only I assigned the scene. The crack was not assigned. Okay. So the crack assignment process is like first we have to create see the crack type of crack is contour integral. Then the first contour region. So we have to select a region. Then crack tip. Then the direction of crack enlargement is the direction, and then we have to go here. This point is for representing the quarter noded or something, quarter noded element, and this is the quadratic element when it is to be degenerated into a collapse into a triangular element. This option is to be selected. So with that, this side of the crack is assigned, and we have to do it for the other side separately. That is the thing because we cannot select two region as the contour integral region. So this is the contour integral region. Because if we select two regions, it will not take it. And that is the reason we are defining separately. Okay. Then comes the this thing, effective. Then the direction. Um, we selected. Oh, it got mistaken. Edited first point, second point. Is it now proper? Yeah, it's now proper. The other things has to be the same 0.25 meters. Okay. So now two ends are defined as two separate cracks. Having done that, we can directly move on to the nodes is already there. We saw. Okay, this thing, everything has to be. Last time we spent time in this, we have to ensure one thing. Not many. That all are quadratic elements. That's it. All are quadratic elements. That's the only thing we have to. Why is it asking triangular? Oh, I think we didn't get them. Okay, just a minute. We have to first the sweepable mesh we have to define. So that is first step is to yellow thing is suitable match. So we have to spot dominated suitable match. Okay. After this suitable match assignment, then we can go for quality thing. Mm, okay, done. Then we can go for quality. Why is it triangular? I think I have not assigned it for the outside region. That's right. Outside region mesh control is also quite dominated. Median accepted. Okay. Then okay, done. Then let us see. Still it gives, let us see. Still it is giving that quadratic element, reduced integration. Now this modified is shown, but we are not using any triangular elements. Let us, okay, if in case error comes, we'll untake it, but let us have it. So, okay, reduced integration is there by default for all, so I have not touched it. If it is not there, it should not be there for any. Then otherwise incompatibility issues will pop in. So in order to avoid that, we have to just see that it is of the same type. You can just go to job, just run it again. But in some parts of the okay that we have changed the geometry. Some issues has happened in the this thing. See, section is there. Section assignment. See part. Okay, so this is the section where the assignment is not there. So for that, what we have to do, we have to just click section assignment for these two regions and done in section one only. Okay, then this now whole part is green. We can go back to job and complete our run. Before that, meshing, we have not done. We are forgetting so many things. We just did everything except for the main thing. We have to do the meshing. Okay, so we did the meshing. Now we see that there is a little code. So let us make it little fine. So what? How to do it? These two things we need to make it fine. And not required. This is not required. Okay, this is not required. So this to be made fine by numbers. We can make it to apply, delete, then we generate mesh. So now we did everything. So we generate the mesh, track everything. Now there shouldn't be any problem. So section assignment was a problem. Then meshing was a problem. That these are the two things we follow. Now again, third thing. What is that? Following parts or the part inside contain both modified quadratic triangular element or thing has also, which I doubted, has created a problem. So let us see how to resolve it. So this problem was because let us see that we are doing some mesh here. Yeah, so if I just click it, I don't know how it has come. Let us to be we created it. Let us see. We have clicked and ensure that the modified the contour integral graph are not associated with any active structure. It is saying that you have not requested anything with respect to that. That's just a warning. We can simply skip it, but for the time being, we'll not skip it. We'll just get a value for that. So for that, we have to go here. We'll stay output. We'll create a new. And, what is that new request? So we can create a new request, or else you can. Okay, let us do it by creating a new request. Go to the track, and track is track 2. Here itself, we could have given that another request in the previous one, but then we'll do it. So in this case, we'll do it for 5 contour and just as intensity factor. Let's see this rate. We are trying now. Then we see that these are almost same. These are expected to be almost same. So now we have answered all the questions which are being raised by this. So now it has not given any of the warnings. It has taken the job for running, as we can see. So we find that it has raised certain queries, questions, and bottlenecks. It has highlighted the bottlenecks which we have resolved, and we are seeing that it's running. It's expected to give the result soon. Once the result is yes, the result is out. We can see that it will open up. Yes, it is opening up. It is behaving perfectly as we expected. So now we'll go and see how much is the stress intensity factor. So for that, we have to go to the folder where it was running. So this is running in the temporary folder, which I didn't transfer the location. So the file is this one. So here, if we see, um, there are two cracks, yeah, crack 2 and crack 1. Okay. Because if we see when there is a edge crack, the stress intensity factor was more. And when we see this, the stress intensity factor is less. So if we can go to the closed form solution, we can calculate, we may find it is less. And from our intuition also, edge crack is more dangerous than the inside crack. So edge crack is more dangerous. The SIF is more there. Here the SIF is considerably less. It will be like 10% less, 10% less or so. So this is how we have done the calculation. Uh, Thanks a lot for watching. We can have this animation also before closing. Um, just animated. This is how the crack will open. So SIF, stress intensity factor, is the technology where we can, which enables us to predict when the crack is likely to grow. After it grows, at what which rate it is growing, where it is growing to, those things are beyond the scope of stress intensity factor, SIF. So stress intensity factor is a product of LEFM, that is University of Fractal Mechanics, which help us to determine when a crack is expected to grow. Once it is gone, it will lead to failure. That's a separate story. But then this is how the use is of SIF is. Thank you for watching.